Hello, class. My name is Brandy Roan, and I'm doing my midterm on quantitative analysis. So I ran a t-test where my hypothesis was there's no statistically difference between the wide receivers and running backs from 2016 in the 40-yard dash. Skewness and kurtosis, the data is normally distributed. My F-stat, from that, according to my F-stat, which is at a 0.07, was greater than my F-critical, which is a 0.53, so the data is unequal. Continuing with the t-test analysis, with the hypothesis stating that there is no statistically difference between the wide receivers and running backs from 2016 in the 40-yard dash. So I did a t-test assuming unequal variance. So my t-stat, with it being 0.27, which is less than the 2.02, there is no significant difference between the wide receivers and running backs from 2017 in the 40-yard dash. Then I looked at my p-value, and according to the p-value, which I got was 0.39, was less than the 0.5. So that concluded that there was a significant difference between the wide receivers and running backs from 2016 in the 40-yard dash. So my hypothesis was rejected. I did an effect size, which I calculated the effect size for the difference between the two groups, and that equaled the Cohen's d scale of 0.07, which is considered moderate. Then I went on to do a correlation analysis. Hypothesis was there is a statistically significant relationship between the 40-yard dash and bench press of the 2016 in the NFL Combine. Skewness and kurtosis, the data is not screwed, so it's normal. The correlation results, I got the correlation between the 40-yard dash and the bench press gave me an R value of 0.75, which is according to the significance table. This is statistically significant at the 0.5 level. Therefore, the hypothesis is accepted. Then went on to do an effect size again, and so according to the Cohen's d scale, there would be a large effect size because the correlation is greater than the 0.5. And here is my graphs showing that the bench press with the 40-yard dash. So my R value gave me a 0.75. So that's stating that there's a 75% chance that the bench press correlates with the 40-yard dash times. And then I did a regression analysis, which I hypothesized that height, weight, vertical jump, and broad jump can be used to predict the 40-yard dash time. I did skewness and kurtosis. The data is normally distributed. Initial regression I had was height, weight, and vertical jump and broad jump are all three factors predicting 40-yard dash times. And so based on the height, your weight, your broad jump, we can predict that your 40-yard dash time, we can predict that time about a 70.3% accuracy. And then here is my graph showing that, so the relation between the actual and predicted 40-yard dash time. So as you can see with the line here, it's gone in a positive direction. So you can kind of see that with my R value at being 70%. So 70% chance that we can predict that our 40-yard dash, that the weight and the height and the broad jump has on our 40-yard dash time. And so here's my regression equation there. And lastly, we did an ANOVA analysis, which I hypothesized that there is a statistical difference between the 40-yard dash time of the wide receivers in the 2016, 2012, and 2007 NFL Combine, which the skewness and kurtosis, the data is normally distributed. And I did a one-way ANOVA analysis, which the results from the ANOVA suggest that there is no statistically significant difference between the groups. So with the hypothesis, I did an effect size estimate. So between the 2017, 2012, there was a small effect, and then 2017, 2007, there was no effect at all, and then 2012 and 2002, there was no effect. So we can conclude that there's really there's only like one small effect that these have on the 40-yard dash time. And in concluding summary, so basically my t-test in 2016, wide receivers appeared to be just as fast as running backs in 2016. The correlation, the more you bench press, the faster you will run, and vice versa. So that's the summary of the correlation analysis. For my regression analysis, it's said that height, weight, and vertical jump and broad jump all have influence on the 40-yard dash time. And then with my ANOVA analysis, no statistical significance difference because there was only one small effect size. This concludes my presentation, and I look forward to getting your feedback.